Hello to you algebra experts out there and soon to be algebra experts. I am making this video for my friend John, but these are topics that a lot of algebra students struggle with, and so I thought I would go ahead and make it a little bit more generic to everybody. But I'm specifically using problems that John has to do in his homework. So these are things that in every Algebra 1 class you have to learn how to do at some point, and that is basically finding all the features, finding all the characteristics of the graph of a quadratic function. And we are specifically going to be looking at ones that are given to us in standard form. All right, so we are going to find the vertex. We are going to find the equation of the axis of symmetry. We're going to find the y-intercept. We're going to figure out from all of this from the equation in standard form what direction our parabola opens, up or down, whether we have a maximum or a minimum at the vertex, and finally what our domain and range are. Right, so let's start out with, and for his assignment, this is number 10. And here is the equation, and it is in standard form. Now let's talk about what standard form is first of all. Standard form is like this. At this point, we're looking at it as y equals, but sometimes you'll see it written as f of x equals, and I just didn't want you to think that that was really any different. I mean, we would deal with everything the same way if it was f of x equals. Okay, so basically, that's what we have here. We have a times x squared plus b times x plus c. It's in descending order in terms of exponents. In other words, this is x to the second, x to the first, x to the 0, so it goes down. And the a and the b and the c are the coefficients. Now, coefficients are numbers out in front of a variable. So basically, the coefficient here, a, is -1. Here, b is 2, and c is 1. A, B, and C will never have an x on them. It's really just what's out in front of your x part. So whatever's out in front of x squared is the coefficient of that. Whatever's out in front of x is the coefficient of that. And whatever is just your number by itself, it's kind of like it's the coefficient of x to the 0, but really we also just sometimes call that the constant term. So C is a constant. All right, so when you have a quadratic in standard form, first of all, let's just talk about what the graph is going to look like. I mentioned it a second ago. It's going to be a shape we call a parabola, and that was not the most smooth parabola. Sorry, it kind of jig-jagged there, which either opens up or down. Okay, there are parabolas that open left and right, but you won't get to them in Algebra 1, and they're not quadratic equations. They come from basically the opposite. Instead of squared, it's square root. But we don't have to worry about that right now. So every single parabola has a point where it turns, a turning point. And that turning point is either the highest point or the lowest point, and we call it the vertex. If your parabola opens upward, your vertex is at the very bottom, so that's a minimum. So it might seem a little bit counterintuitive that if it opens up, in other words, the arrows on the ends are both pointing up, what it has is a minimum. That's because it has a point where it turns around and it doesn't ever go any lower than that. If it opens down, if the ends are pointing down, it has a maximum. And either way, the minimum or the maximum happens at the vertex. So finding the vertex is really a very important thing. Another reason finding the vertex is very important is because quadratics or parabolas are symmetric on either side of the vertex. Okay, so whatever happens on the left and the right mirror each other, and the vertex is right in the middle. So that's why it's important for us to know where that is. So finding the vertex from standard form is a pretty simple little formula. Okay, it's your x value is going to be -b over 2a. All right, now vertex is a point, so we need an x and a y, but this is just the x value. This is also something we'll come back to in just a second. But so we're going to fill into that, and that's -2 over 2 times -1. Be really careful with your signs. It's very easy to mess them up. And you get 1. Okay, so what that tells me so far is that my vertex has 1 for its x value, but we still don't know the y value. Well, if we have an x value and we have a whole equation and we need the y value, we just plug in. So I'm going to go back up here and I'm going to say, okay, y is, using this, I'm going to plug in my x value of 1. And I get -1 squared plus 2 times 1 plus 1. So that's negative 1 plus 2 plus 1. Keep in mind here, the negative is not being squared, okay? Because we're plugging in behind the negative. We're plugging in the 1. This is x squared. If the whole thing was going to be squared, it would have to look like this, and it does not. So this negative is separate from this x squared. So we're squaring the x, and then we're putting that negative on the answer. So this is going to give me 2. So that tells me my vertex is at 1, 2. So that's the first thing I needed to find out. Now, let me, I think I'll go ahead and sort of start my graph here. Vertex is at 1, 2. So there it is. Okay. Now the next thing I need is my axis of symmetry. We just said that every parabola is symmetric about the vertex. It's really about the line that goes right down through the vertex. That line is called the axis of symmetry. I'm sorry that mine doesn't look perfectly symmetrical, but it is. So it's a vertical line. Anytime we have vertical lines and we're dealing with coordinates in the coordinate plane, vertical lines have equations that are x equals some number. That's always how a vertical line works. So on my graph, a horizontal line, like a line through here, would be like y equals 5. Or a horizontal line that goes through here would be y equals 1, meaning it's the set of all points that have a y value of 1 or a y value of 5. Vertical lines are x equals some number. It's the set of all points where the x value is the same. Okay? So we know that whatever our vertex is, if that vertical line has to go right through it, it's going to have the same number value as the vertex did. That vertex was at 1, 2, and we just said it's x equals, so whatever the x is here, that's the number for my vertical line. So the only way for a vertical line to go through the point 1, 2 is if its equation is x equals 1, the same as that x value. So whatever your vertex is, every single time, your axis of symmetry is going to be x equals whatever the vertex's x value is. So my axis of symmetry is x equals 1. Now, a couple more things I want to say about that. One is sometimes people want to find the axis of symmetry first. Your teacher may have suggested you find this first, because a lot of times we just consider this equation right here to be the equation for the axis of symmetry. I mean, that's what it's giving me. X equals, and we got 1 here. Well, that's what that is, x equals 1. So this really is the equation for the axis of symmetry. Another way of thinking of it is you're just finding the axis of symmetry at the same time you're finding the x value of the vertex. They're just always going to be the same every single time. All right. Another thing you need to know, be very, very careful about your axis of symmetry is you want to write the full equation. Do not just write the number 1. This is an equation of an entire line. It's that entire dotted line we just drew. If I just say the axis of symmetry is 1, what does that even mean? The point 1 on the x-axis or on the y-axis, or 1 what? We need the entire equation. Okay, and it matters because it could be, you could have a line y equals 1. So it matters that it's x. So you have to write the entire equation for this. So make sure you write an entire x equals 1. Okay, teachers count off for that very, very frequently. And we frequently encounter people who forget to write it. All right, so we've got the vertex. We've got the axis of symmetry. Where was our little list? Let's go ahead and check off what we're doing. All right, next we need to find the y-intercept, okay? Finding the y-intercept with a quadratic is really exactly the same as finding the y-intercept with any other type of equation ever. And that includes equations that you've never even seen before that you'll get to in trig or calculus. And that is, y-intercept is the place on the y-axis where the x value, well, it's the place where your graph crosses the y-axis. It's the place, the point on the y-axis that your graph touches it. Okay? Think about all the points on the y-axis, up and down the y-axis. Like this point is 0, -1, 0, -2, 0, -3, 0, -4, 0, -5, 0, 0, 0, 1, 0, 2, 0. The thing they all have in common is that I'm starting with 0, which means the thing they all have in common is the fact that x is equal to 0 there. So anytime you want to find a y-intercept, you plug in x equals 0 and find out what you get for y. So we're still working with our original equation, and we're going to go ahead and find the y-intercept by plugging in x is 0 and seeing what our y value is when x is 0, which means basically when we're on the y-axis. So y equals negative 0 squared plus 2 times 0 plus 1. So that's just 0. This is just 0. Sorry you couldn't see it. It's 1. So my y-intercept is not a whole line, it's just a point, and that point is 0, 1. Now, helpful hint, look back up at what we have, and let's think about the standard form. If I plug in a 0 here, this whole thing is going to be 0. If I plug in a 0 here, this whole thing is going to become 0, which means that really your constant term will always be your y-intercept if you're in standard form. You have to be in standard form to just use that. But if your equation is in standard form, you could just go, I see a number by itself, that's my y-intercept. Okay, so here my y-intercept is 0, 1. That means this point right here is my y-intercept. Now, the thing that tells me, which maybe I didn't know before, and we'll talk about how we would know, is that this parabola is not going to be opening upward. This parabola is not going to go like this, because there's no way it would touch, whoa, sorry, I didn't mean to write that. No way it would touch the point 0, 1 if it was going up. This parabola opens down. Now let's talk about how to know that from the very beginning. Whatever the sign is of your leading coefficient tells you. So remember, whatever this leading coefficient here is A. And if it doesn't have a number, like ours doesn't have a number, that's like a -1. It's like there's an imaginary 1 there. Okay, so A is -1. So if A is negative, which means less than 0, then your parabola opens down. If A is positive, which means greater than 0, your parabola opens up. So that's actually one of the very first things you can see on a parabola is look right behind the equal sign. This is assuming it's already in standard form. Right behind the equal sign, is there a negative? That means it opens down. Is there not a negative? That means it opens up. Okay, so we have figured out 2 more things. We have figured out our y-intercept, and we also figured out, not related to the y-intercept, whether it opened up or down. And there's only 2 options. It's either going to open up or open down. Okay, so let's look at our graph. We know it's going to open down. This is where we are right now. This is all we got. Now, one thing I could go ahead and add right now is this. We said way back at the beginning, parabolas are always symmetric with respect to the axis of symmetry, which means one side of it is reflected across the axis of symmetry to get to the other side. Like this pink dotted line is my axis of symmetry. It's like I could fold the parabola across the axis of symmetry and have it match up. So that means every time you find a point on one side of the axis of symmetry, there's going to be a mirror image point on the other side. Okay, so if I go down 1 from here and I have a point 1 to the left, then going down 1 would get me a point 1 to the right as well. So I also know that point. Just by knowing this point here, I also know that this point, this is 0, 1, this is 2, 1. That was 1, 2. I wrote it so far out here because I wasn't sure what the parabola was going to do yet. All right, so we can go back and find some more points later, but that one, we just, by knowing this is here, go as many points, the opposite on the same horizontal line. Don't go up or down. This is 1 to the left of the axis of symmetry. That means there'll be a matching point 1 to the right of the axis of symmetry. All right. Now, let's see. We need to talk about max or minimum. Well, we kind of already did right here. Okay. Every time your graph opens up, your parabola opens up, your vertex is giving you a minimum. Every time your parabola opens down, your vertex is giving you a max. Now let's think about what we mean by max or min. What we really mean is we mean a low point, a minimum in terms of height, or a high point, a maximum in terms of height. Okay, so this is like we're talking about a minimum like a low. This is a maximum like a high. Low and high, we're talking up and down. That's stuff that deals with y. Okay, the y-axis is what tells us the up and down. X-axis tells us left and right. But if we're talking about minimum, we mean the bottom, that's a y thing. And we're talking about maximum, we mean the top, that's also a y thing. Okay, so knowing that my vertex is 1, 2, the y value here is going to be your max or min. So each of the two parts of the vertex, the x and the y, have a special meaning. The x is always your axis of symmetry. The y is your max or min. This one opens down, so it will be a max, which basically means it's the highest that this parabola ever goes. The parabola never goes above 2. It goes down from here. Okay, and let me see if I can quickly find a pencil. I keep wanting to draw my little swoopy thing here, my little parabola, every time I talk about it, just to point out it's opening down. But I don't really want to make it permanent because we need to find another point or two to figure out where exactly it goes. And that's the very last thing, I think. Yeah. Oh, no, it's not. We got to talk domain and range. All right. So we can do that as soon as we found two things. The domain and range we can talk about as soon as we know whether it opens up or down and where the vertex is. And here's why. For every parabola ever, your domain is all real numbers. That means there's no limits on the domain. I can plug in any x value I want. Okay, that's true for every quadratic. The domain is all real numbers. Sometimes we write it like that. Sometimes we write it in what's called interval notation, which means from negative infinity all the way to positive infinity, all real numbers. Now the range, this is where we get into the whole idea of max and min. Remember, the domain is x values. The range is the possible y values. Well, we just said this is a maximum value. Right here, 2 is. The y values never go any higher than that. So that means the range can't go any higher than that either. Okay, so there's a couple of different ways we can express that. Basically, all y values lower than that are fine because this is going to keep going down forever on either side. But the y values can't ever get any higher than 2. It's almost like a max is a ceiling. A minimum is like a floor and a maximum is a ceiling. And my range is going to basically have to say my y values are everything below 2 and also including 2. So a couple ways we could express that. We could say y is less than or equal to 2. And it'll always be less than or equal to if it's a maximum. And if it was a minimum, it would be greater than or equal to. If we want to do it in this interval notation, that says the y values go from negative infinity up to 2. And we actually put a little bracket that means it actually can be 2. We don't ever use brackets with infinity symbols because you can't actually land there. You can't be on infinity. It's not a place. But you can be at point 2, and this parabola does go there. So it kind of depends on how your teacher wants you to write these, but these are saying the same thing. These are saying the same thing. All right. So now we've got everything we wanted to find. And the only thing we want to do left, the only thing left we have to do is to make this graph just a little bit better by picking another point or two. Some teachers will say you have to have at least 5 points showing on your graph. Some teachers will say, you know, it's okay as long as you have it one other point other than the vertex and you have it, you know, pointing the right way up or down. Really, you just have to go with whatever your teacher has said. It's not a bad idea to go ahead and have 4 or 5 points. So how could we get more points if we don't have them? Well, here's our equation. One way you can always find individual points for a graph is just plug in, kind of like when you're making a table of values. You pick whatever x you want to, and I'm going to go ahead and write that equation here so I can cover it up and not have to keep moving this down. That was my original equation. I can pick any x I want to and see what y value I get when I plug in. So I've already used x values of 0, 1, and 2. Let's see what happens when you use the x value 3. Well, we get negative 3 squared plus 2 times 3 plus 1. That's -9 plus 6 plus 1. That's -2. So go over to 3 and down 2. The point 3, -2 is on my graph. Now remember we said that we can use the symmetry to help us here. Okay? -2. This is on the same level, so to speak. Everything at -2. This point right here, remember this axis of symmetry is at x equals 1. So 3 is 2 points to the right of that, or 2 units to the right of that. So if I go 2 units to the left of that, symmetry tells me I also have a point at -1, -2. So now I've got 5 points. You could keep going. You could go ahead and plug in 4 and see where x goes for what, see what y value you get for 4. You could plug in the -1 and check and make sure you get -2, and you should. If you don't, you probably plugged in something or you did some sort of calculation wrong. But I am satisfied that 5 points gives me enough to go ahead and draw my parabola. A couple of things when you're drawing your parabola, try really hard not to make it look like a V. One helpful way to do that is to sort of make this almost like a little semicircle right here where it turns, and then go down on either side. Also, these don't ever become exactly vertical. Don't think that this becomes a vertical line and going straight up and down. It is constantly going out, 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 out slightly. Okay, you just can't tell because it's very, very slightly. So that's part of why my domain is all real numbers, is while it looks like this is going down, it's getting wider and wider and wider as it does so. So eventually it's getting to all these x values way out here. It's just way down off the bottom of the graph when it does so. I hope this has helped. This has just been a summary of pretty much everything you generally need to know when you're graphing a quadratic. And I'm going to go ahead and do a couple of more quick examples just so you can make sure you feel comfortable with them, since we really did everything with just one example. This is number 12 from John's assignment. All right. And that, first of all, first thing that occurs to me now when I look at it is this is positive. Remember, this is my A, B, C. Keep in mind that this minus is part of B. It's -8 for B. So this is positive. So this is definitely going to open up, which means the vertex is going to be a minimum value. And it also means, thinking about that range again, the range, this is now like the lowest y could ever be. So y can be everything above that. So it's going to be y is greater than or equal to whatever that minimum value is. Let's put a blank there to fill in later. All right, so I'm going to start by finding the vertex. So I do x equals -b over 2a. That's going to be +8 because b itself was -8 over 2 times 4. 8 over 8 is 1. So this not only tells me that the vertex has an x value of 1, so that's the first thing that tells me, but it also tells me that my axis of symmetry is x equals 1. All right, now going back, I'm going to plug in 1, x equals 1, into my original equation so that I can find the y value of the vertex. So y is 4 times 1 squared minus 8 times 1 plus 9. That's 4 minus 8 plus 9. -4 plus 9 is 5. So there's my vertex. Now, we talked about how the 2 points, or excuse me, the 2 coordinates, each tells me something special. The x tells me the axis of symmetry, so I already got that. Remember that the y tells me the highest y value or lowest y value because the vertex is my turning point. We know that the minimum value here, or that the vertex is going to be a minimum. Okay, so what that tells me is that all the other y values have to be above that. So y is greater than or equal to 5. That's what that tells me. It tells me that my minimum is 5 and that my range is everything greater than or equal to 5. The other things I need to know, well, domain, remember, is all real numbers. So x can be anything. Let's see, what else did I need to know that I haven't hit yet? much rustling of papers. I've got my vertex, got my axis of symmetry, y-intercept. We haven't found that yet. Now remember, if you need to find a y-intercept any other time, you always, and even this time, plug in 0 for x. But this time, when I'm in standard form, 0 for x makes this whole term become 0. This whole term becomes 0. That's going to be my y-intercept. It's the same thing you would get if you physically plugged in 0 for x, and that is 9 is your y-intercept. So I'm going to use that point to help me get my graph nice and accurate.